Hey everybody, welcome to another episode of Doubly's Talk Tech. My name is Mike Hoffman.
My name is Daniel Bogdanoff, and we are back with the fantastic Jit Lim. And this time, last time we talked about USB 3.2, kind of generally in specifics. And after the camera turned off, we started talking about some of the measurement challenges and what people are struggling with on 3.2. Because Jit was telling us there's a lot that plays into making a spec like that work. So we were hoping you'd enlighten us a little further about 3.2.
You bet. So at the previous podcast, we talked about how the USB 3.2 would run in by-two mode. So instead of one lane of 10 gig, now you got two lanes. Well, so the problem when you have lots of signals is this thing called crosstalk. So even though Type-C connector is a great connector, because it's so small and you have these really high-speed edges, crosstalk is a significant problem during the operation of a USB 3.2 system.
That makes sense. And that's basically like, not EMI, but EMI that influences other traces on a board or in a cable.
Yeah, it's just very simple crosstalk. And so when you do the testing, in testing, what we try to do is emulate a real world condition. So when we do, for example, scope or transmitter testing, we need to be able to capture all four lanes of the data to see the crosstalk effects. So that makes it complicated. When we do, say, receiver testing, you can't just test one side now. So you need like dual lanes on a bird to send a signal when you're doing the testing. So the whole point is you want the testing to simulate real environment. And so to comprehend crosstalk, you got to look at all four channels or all four pairs running at the same time. So that adds a tremendous amount of complexity. But that's how the product works. All four lanes are running. In fact, in Thunderbolt mode, that's what you do. When you test, you always are adding crosstalk sources in both TX and RX mode.
So when you're in the early stages of developing a spec change like this, how much do you want to do but just can't because the testing technology doesn't exist yet?
I think customers who are doing the early silicon are quite innovative. So even though to your point, the CTS, the compliance test spec is not done, but customers can't wait for that. So there's a lot of customers already testing. And what they do is the word for that is what they call BKM, best known method, which is do the best you can under the circumstances you have. So what you never do is go, well, the spec's not done, so we wouldn't test. That's just not the way.
Yeah,
you do the best you can with the information.
Okay.
So that's really the right thing to do while waiting for the CTS, the compliance test spec, to be released.
And that's one of the advantages, I think, and a reason of being on the board and helping define the spec is you can go back to your lab and your group and say, hey, this is kind of where we're going. Let's start developing. And then when the spec releases, you're way ahead of anyone who didn't have buy-in into the spec in the first place.
That's absolutely correct. Yeah, we have to be working very closely with our customers who are writing the spec. We need to work closely with our customers who are actually developing silicon out there way before the compliance test spec is done. So it's a really important part of what I do in my role, which is engage these customers. In fact, 2 weeks ago, I was at Keysight World Japan, and one of our key customers who is doing a lot of this what they call pathfinding work presented some of their best-known methods for testing. It's not compliant yet, but it's like, this is how you should be thinking about testing, and that's what we do today, even though it's not officially signed off, which is, don't wait. You want to be first to market? You can't use the excuse of not having a test spec as the excuse for, well, we can't do anything. If you wait, you will be behind. Our customers will be behind. You can't do that.
Well, and that's the advantage of like test measurement companies being on those types of boards is the hooks between. I'm just gonna say a couple company names, but I don't know the details of intimately how things are working. So like Intel, for example, we work very closely with some key people there to make sure that we can support their test needs. And then we also kind of get to see what they're working on, some of these best known methods that may or may not be public so that we can kind of adapt to what eventually will be the spec. But also for us, when the spec comes out, we want to have a full suite of everything ready so that people can.
That's absolutely correct. And Intel would be one of these key silicon vendors that we work closely with that are driving this pathfinding work in these next generation standards.
How many different companies are out there developing USB 3.2 silicon? Is it so? For example, if I look at an end product, a consumer end product like a USB 3 cable or something, and I buy it from Anker, is Anker developing everything in there? Are they sourcing parts and controllers and things like that from like a couple select companies that are USB IF approved, and are they the ones doing a majority of the testing? Or is everybody testing all the way up the ecosystem?
So there's actually a large ecosystem used a cable, right? So the cable vendor sometimes is just worried about the materials, the conductivity. But if they have retimer chips in there, there's a high likelihood they would not be the designer of the retimer chip. So you got the ecosystem all the way from a retimer chip vendor to an integrator to a cable manufacturer. And it gets even more complex when you have like a host board, which you have what they call a string ODM, original design company, which designs the board with chips
like
from
an OEM
vendors, OEM, who do the design, but then the product's branded with a different company name, and then it's got chips from almost everybody. So the ecosystem is fairly, it's well oiled, but there are many players involved in the production of even a simple cable, because all the components come from different vendors, if you will.
And every layer in that onion, are they having to go to the USB IF for certification? Like the person making the retimer, person making the cable, do they all come back to you? Or is at some point it's like all the parts you're using are certified, so you're kind of
So the
certified?
Final product, the one, when you see the USB logo, clearly needs to get certification. Generally, a silicon vendor who builds a chip does not need to, but to illustrate that their products are capable of being certified, most silicon vendors will build their chip into some kind of a final product with a port and then send that to certification such that they can say, look, our chip is certified in this reference design. You can use it if you follow our guidelines.
It's not required, but it'd be kind of silly if you didn't.
Yeah, because then the customer go, well, what's your proof? You telling me the chip works doesn't mean anything. But if you tell me you got certified, then it has a lot more clout, if you will. So that's how they do that.
To have a good reference design is definitely an incentive for the engineering teams to go with them over someone who just has a chip that
says we can make it.
Yeah,
exactly. So that certification, it's the vast majority of silicon vendors will build up a platform, take it to the workshop or take it to the USB IF pill lab, get it certified, and then say, look,
that makes sense. Yeah,
we got great products, it passed. Now you can use it using our design guidelines, of course.
Gotcha.
Somewhat related, I saw listened to maybe a podcast that was really interesting about Monoprice, who basically started their business on building cheap HDMI cables.
Yeah, okay. I was trying
back in the day.
Right. I think I've bought their cables before. I was like, why do I know that?
Because like when they came out, HDMI cables were like $20-$30 each, and they pulled one apart and said, oh, we could make one cheaper than $20 and have basically built a business around reverse engineering products like this and selling not knockoff versions, but reverse engineered and maybe slightly cheapened versions of them, like TVs and everything. And they have a whole team of engineers who just like buy nice fancy stuff, tear them down, and
price it all out.
Price it out, find vendors, that type of thing. Or they'll even work with the same vendor, but work out different arrangements or different, I don't want to say quality standards, but different ways to make production cheaper. So as you're talking about this, I'm thinking kind of in my head, in the back of my mind, like, oh, this is interesting. Like the early adopters are definitely going to go with this silicon reference design, like well-established companies. But down the road, who knows, how all that's playing out.
Absolutely. There's so many pieces. If you look at a simple cable, it looks like a simple cable. But for example, the metal pieces, the connector pieces, they'll come from a totally separate vendor because there are vendors who are specialized in the metal pieces, if you will, the plug or receptacle. Then you got the molding, the black part of the cable. That usually comes from a different vendor.
Makes sense.
And then the wires inside and the cabling, that's also from a different vendor. And then the retimer chips clearly from different vendors. So even on a simple looking cable, you got multiple vendors involved in making this simple cable work.
Yeah. It's crazy stuff. Like in this building, I think we have some BNC cables around here that were literally wire pulled, like in this building. Like back in the day and everything. And to do something like that is just not even feasible anymore. Or else your products are costing triple everyone else's because you're taking these weird approaches to building things.
So is there anything new in the certification process for USB 2.3 or 3.2 versus 3.1 or 3.0? Has anything changed as far as getting your certification or any kind of compliance testing is concerned?
At a high level, the process didn't change, but the 3.2 compliance certification is going to be significantly more complex because there'll be no new equipment requirements for looking at dual channel. There'll be new requirements for getting these DUTs into these special test modes. The retimers, which we didn't talk about, I mentioned in the previous podcast that they're very complex silicon. Testing retimers, it's going to be non-trivial because they're very complicated. They're essentially like a couple of products built into one.
Because it's both a full receiver and a full transmitter.
Exactly correct. Twice.
It's just not processing
by
data.
2. There's like 8 new products in there because you've got TX, RX going this way, TX, RX, and then twice of those on the other CC port. So even though these things are, say embedded in the cable, they're very complicated, and they're embedded in the hose or embedded in the cable. So it makes the testing, honestly, a lot more complicated. But again, that's what our customers want. They want high performance. They want long cables. They want a seamless experience, right? But but the fact is behind the scenes, the testing will get considerably more complex with a 3.2 spec.
So when you're coming up with this new spec, are you just defining the protocol layer? Or are you also defining are you just defining what a retimer does? Or are you doing like reference designs? Are you defining all the test procedures? Kind of how far do you all go?
Yeah, so Keysight's a test and measurement company. So what we do really in this case is we really adhere or listen to what the customer wants, which develops the spec. But really the spec doesn't talk about how to test. What the spec says is these are the performance requirements needed to meet the customer need.
Okay.
When Keysight really starts actively contributing is when we do the CTS, the compliance test spec. The spec doesn't say how to test. The spec says it will be 20 gig or 40 gig, 100. And we go, okay. And then when we go to the CTS, that's when we say, okay, now let's collaborate and figure out how we can test these things.
And that's usually some sort of subcommittee, correct?
Yeah, it's a separate group. So there's a spec group that develops how fast the thing will be. For example, this thing's going to run at 200 miles per hour. Then the other group says, all right, now how do we test that it's really running at 200 miles per hour? So there are two groups, one that says what the spec should be, and the other one, which we spend a lot more time on, well, how do we test this thing? So they're really two separate. In a sense, Keysight really is not in position to say, well, you shouldn't go to 20 gig. Or
right.
We're not in the business of defining what the thing should do. We're definitely in the business of once you tell us what the thing spec is, we will help you test it. So that's a clear delineation between the two worlds, if you will.
That makes
listening
sense.
Intently and being able to test.
Okay, very, very cool. What else are people struggling with? Do you have any advice for people who are out there and thinking about implementing 3.2?
Yeah, as far as I know, I think our 3.2 compliance test application is launching relatively soon. How many people are even testing 3.2 yet?
There are a number of early silicon vendors who are doing that at these workshops. Even though the CTS is not released, the leading edge folks have been bringing. We've been seeing 3.2 products in the workshops, Plugfest for maybe a year and a half.
Oh, wow.
So we actually been testing. Again, like I said, best known method, or what they call FYI. So there's considerable amount of energy in there. And are they shipping yet? It's not clear they're shipping anything yet for a 3.2, but there's a lot of testing going on because customers like us, they want to be first to market with a 3.2 product.
Yeah, makes sense. Well, because then you have a significant performance advantage over everyone else. So it's, the badge is nice, but to actually double everyone else's performances.
Yeah, that's
huge
really
market advantage.
Critical. So,
we haven't seen you much in the office lately. So, to Daniel's question, I'm assuming you're out talking to customers, helping them deal with these struggles. So, kind of what are they dealing with? You mentioned crosstalk. You mentioned
one is down to basics of. I mentioned this at a previous podcast too. When you got 10 gig over electrical cables or PCBs, unfortunately, they're just failing. And
Yeah.
failing is a bad word. Customers hate that, but it's very difficult. They just want to see
I don't like it either.
pass, And so I would say on a daily basis, we see, marginal performance, which means that sometimes it passes and fails. It's very disheartening to see that, but
Yeah.
it's hard. So, the spec is complex. The performance requirements are severe. It's not easy to pass tests. So there are products passing, they clearly do well, but many products do struggle with marginal performance. I wish, things were easier, but they aren't because these numbers are just mind-boggling. 10 gigabits over a long cable, over a long PCB. There are a lot of challenges getting these products to work well. Very difficult.
You mentioned earlier in the previous podcast that it was hard to get obviously 10 gigabits per second is hard on any medium, but on cheap PCBs. And when you say cheap PCBs, do you mean materials or production tolerances?
Yeah.
Or?
If you look at the a link, there is a transmitter, a receiver, and a channel, right? So you got silicon and transmitter, silicon and receiver, and then you have this PCB or cable. In general, if you look at the way the specs are written, the onus, the burden of overcoming the channel is in the silicon. So you see very sophisticated, what they call equalization, transmitter equalization, even more sophisticated receiver equalization.
Okay.
Now, for a while, they also put these things in the cable, which is where active cables come in. But generally, the ecosystem is such that they want to use the existing low-cost PCB processes to make low-cost laptops. Because today you can buy a 10 gig laptop for less than $1,000.
Right.
So
crazy.
it comes from low-cost PCBs. And so that's what I mean when I say low-cost, high-loss PCBs. I mean, you can make very sophisticated PCBs that have very little loss, but I think the laptops may cost
A lot more. Yeah.
a lot more, and customers don't like that.
Right.
They still want performance and not pay more than $1,000.
Yeah. Makes
So
sense.
that's the nature of the business.
Give it all to me, and I want to pay nothing for it.
Yeah, and we are the consumer is definitely wired that way. They want all the performance with I bought my 10 gig USB laptop probably 3 years ago for less than $1,000. 10 gig, and it had Thunderbolt also on it. So 20 gig Thunderbolt, 10 gig USB for less than $1,000, and this was 3 years ago. So I haven't shopped lately. But,
I remember the first TV I ever bought. I just got done with my summer internship at Intel. It was back in like 2005. I'm making $12 an hour, filthy rich.
yes.
I'm loving life, and so I go to Fry's Electronics and I buy it's like a 37-inch 1080i HD TV, $1,600.
How many hours of work is that?
Yeah, but back then it was like not a bad price.
Yeah.
I was like, it's just what TV. This thing weighed like 100 pounds. It was huge. And now I go so I haven't bought a TV in a long time. The one I have now I found used somewhere. So I pop on a website and it's like, 50-inch flat screen, 1080p, 4K, internet enabled, $150 or something like that. It's unbelievable.
I'll take that deal. Yeah.
Yeah, it's unbelievable where technology's gone.
Yeah.
But
Cool.
How are we doing on time?
I think we're about out of time-ish again.
I'm out of questions to ask you, so that's perfect.
That was that was good. Jit, thanks again for being on the podcast.
You bet.
As you now know, we always ask a stupid question at the end of the podcast. So I'm speaking slowly because I'm trying to come up with one in the back of my head. I do this every time. I know it's coming and I don't prep it. So it's kind of a lot like college. Mike?
Stupid question. Should I make it a really stupid question and have it not even be on topic?
Lean into it, man. Yeah.
Sure. What's your favorite national park?
And why?
And why?
That's a good question.
That's a tough one. I think Yellowstone would be my favorite because I'm big into the animals and the nature, but I like seeing wild animals running rampant around. So
Jumanji style.
Yeah, so I like Jumanji style. I think that's the thing that does it for me to be able to see wild animals not being hunted. Just wandering around, kind of like hometown where I love seeing these deers and bobcats and bears running around. It's kind of neat, Yellowstone right here in town. Kind of, it's a good feeling. So
I'll say
Jumanji
quickly,
style.
If you've never been to Yellowstone, I've been to a fair number of national parks. I don't know, Mike, you have too.
I've been to Yellowstone though.
Yellowstone is spectacular. Like in the sense that it's a spectacle. Like there are things that just like your brain can't comprehend as like normal nature sort of spectacle.
It's like a different planet.
So like things are pretty. Like Yosemite is beautiful and Bryce Canyon is beautiful, but Yellowstone just is a spectacle. So
Huh.
It's a must. It's a must visit at some point. And we're way off topic. Okay. My question will be to Jit about something. What is your favorite PCB material and why?
I don't have a favorite in the sense that our goal in the sense is to help our customers succeed.
Mm-hmm.
So if they want to go low cost, we can help them, enable them by testing. If they want to invest in higher cost, some of these sophisticated material beyond FR4, or even that's actually most sophisticated FR4, we can help them do that. So
Okay.
it's we don't want to. We get actually I ask that question quite a bit. Customers go, what do you recommend? And we really are not in a position to do that,
Right.
Because we're not really into
Yeah. that makes sense.
designing, if you will, but we'll test. So,
Right.
I do
Yeah.
get asked that question. What should we use? And we're like, well, how much you going to pay, right?
What's your budget?
What's your budget? I
Okay.
mean, for our, our new UXR scope, for example, that is not low cost PCB, right?
No.
Those
no.
boards are very, very, I think they're fairly high cost to put these 100
Yeah.
gigahertz plus signals through.
Yeah, we haven't really talked about the UXR much. We kind of got a mild launch, and I think we're going to put more attention on it.
Okay.
A little bit in the fall. But it was launched at Keysight World in Japan, I believe. So I think the Keysight YouTube channel, like the main Keysight corporate YouTube channel, has some talks and maybe a video on the UXR at that. So you should go check that out as well. I'm going to ask you a second question. What is your favorite piece of equipment to test USB 3.2?
Yeah, we can't, so remember earlier I talked about the link. So there's a transmitter, the channel, and the receiver. So you really have to look at it as a complete system. So you can't pick one, because if any of those are not working, the whole thing doesn't work. It's
You have to pick one.
all
Jit.
or nothing.
I'm going
I'll
to
have
make you pick one.
You're really good at being the parent who doesn't want to pick their favorite child.
Yeah, so
You're my favorite 5-year-old.
So I'm pretty geeky, and scopes are most people understand how they work. Most people understand the VNA, but a bird, that thing's a strange beast.
Mhm.
So I like it because I'm a geek. So my favorite strange equipment is a bird.
You
for
can
doing
just
receiver
get out
testing.
now. You're in the wrong building, dude. That's a good answer. The bird is an intimidating instrument, that's for sure. All right, that's all for today. Jit, thank you so much for coming back for another episode. And of course, my co-host, Mike Hoffman. It's good to have you back. I know we had Erin last week. She tried to do you proud in the intro. And I'm Daniel Bogdanoff. Make sure to subscribe to Double E's Talk Tech. Give us a review, and we will see you next time.